Okay, so let's take this other example. A series circuit consists of a resistance 600 ohms, an inductance of 5 Henry, an AC voltage of 15 volts RMS, and frequency 50 Hz is applied across the series circuit. Calculate the current I flowing through the circuit. This current I is still the RMS current. Then the voltage across the inductor. 3. The phase angle between the current I and the applied voltage. The average power supplied. And 5. The PD across the resistance. So what we are going to do now, before I start this, I'm going to draw the circuit, because sometimes you may be asked to draw the circuit diagram. Okay, so if you're asked to draw a circuit diagram, I'm going to have a resistor connected in series with an inductor. Then I'm going to have my AC circuit symbol, and this way. So this is going to be 15 volts. Then the frequency is 50 hertz. Okay, we can quickly go ahead and start solving this. So I'm going to have, so for the first part, we have to find the current flowing through the circuit. Now, based on the parameters that we're given, we need to find the impedance of this circuit. So this is my resistor, 600 ohms, and this is my inductance, 5 Henry. Okay, so for that reason, we need to find the impedance. So recall that the impedance Z is equal to square root of R squared plus XL squared. So from this, my Z is going to be equal to square root of, my R is 600 squared plus XL. We don't have the value for XL, so we have to calculate SL. So XL is equal to 2 pi FL. So that'll be 2 times 3.14 times F 50 times L, which is what? 5. So when we work this out, press this out from my calculator. So this is going to be 2 times 3.14 times 50 times 5. So that's going to give me 1,570 ohms. Remember that reactance is always measured in what? Ohms. And you notice I'm using 3.14 for pi because I was not giving any value. So if you can choose to use any value you wish to, if you're not giving any value, except it is stated that you should use that particular value. Okay, so I'm going to have this here, 1,570 squared. So I'm going to work this out. This is going to be equal to the square root of 600 squared plus 1,570 squared. So that's equal to 824,900. So I'm going to take the square root of this. Square root of this, that gives me 1,680.7 ohms. Again, the unit of impedance is ohms. Okay, so we've gotten the impedance, so we cannot get the current. So recall that the impedance or the voltage from Newton's law, Ohm's law, VRMS should be equal to IRMS times the impedance, because this is the overall resistance. So you can now say that the IRMS current is equals to VRMS divided by what? The impedance. So that will be equal to, so my VRMS is 15 volts as given in the question. So I'm going to have 15 divided by Z, which is 1,680.7. So when I divide this out, 15 divided by 1,680.7. So that's going to give me 8.92 times 10 raised to power minus 3 amp, or 8.92 milliamp. If you want to leave your answer in amp, it's fine. If you want to leave it in milliamp, it's okay. So next, we have to calculate the voltage across the inductor. So we already have the reactance of the inductor. So the current, because it's a series circuit, this is the current IROMS current. So it's the same current that will flow through this, though the voltages may be what? Different. VRO, and this will be what? VL. Okay. So from here, we can calculate the voltage. So let's calculate the voltage across the inductor. So the voltage across the inductor will be given as, again from Ohm's law, we know that VL is going to be equal to XL times IL. Here IL is the same as the current IRMS because it's a series circuit. So that's going to give us, so VL is going to be equal to XL, which is 1570 times the current IL, which is 8.92 times 10 raised to the power minus 3 amp. So when I work this out, this is going to give us 1570 times 8.92 exponential minus 3. So that's equal to 14.00. So that's approximately 14.00 volts. Okay. So next, we have to calculate the phase angle between the current I and the applied voltage. So to calculate the phase angle, you can either use the phase angle is equal to arctan VL all over R, or VR rather, or you can use the phase angle equals arctan XL all over R. So you see, we don't have the VRO, so we have XL and R. So it's very easy for us to use this. So this is going to be arctan equal to arctan. So XL is 1570 divided by R, which is 600. So work this out. We are going to have arctan. So 1570 divided by 600, that's equal to 2.617. So I'll take the inverse of this, tan inverse of this, and that gives me approximately 69.1 degrees. Okay, so that's the phase angle. So to calculate the average power supplied, you can use this formula. The power is equals to IV cos phi, or you can use I square R. So any of this will give you the value of the power. So let's try this. P is going to be I, that's the current, which is calculated the current as 8.92 times 10 to the power minus 3. 8.92 times 10 to the power minus 3 times the voltage 15 cos the phase angle, which is 69.1 degrees. If I work this out, this is going to give me a value of 8.92 exponential minus 3 times 15 cos 69.1. So that's going to give me 0.04473 watts. So let me try it with this, whether we'll get the same answer. P is equals to I squared R. So that will give us 8.92 times 10 raised to the power minus 3 squared times the resistance, which is 600. So that will give us 8.92 exponential minus 3 squared times 600. So it gives me the same answer 0.0447, okay, approximately 4 watts. So you see that you have the same answer irrespective of which of them you use to calculate the watt power. Finally, let us calculate the PD across the resistance. So to calculate the PD across, let me just quickly draw the circuit again. So I'm going to have this inductor, and this. So this is 15 volts, 50 hertz, and this is 600 ohms. This is 5 L. So we have to find the voltage across this VR, and this is VL. Remember, we have already calculated VL the previous solution. Our VL was 14.00. So VL is equal to 14 volts. You know that the circuit voltage is 15 volts. So we can just apply this V squared is equals to VR squared plus VL squared. So VR squared is equals to V squared minus VL squared. Don't forget that this is the RMS value of the voltage here. So VR squared or VR will be equal to square root of V squared minus VL squared. So that will be equal to, so that's 15 squared minus 14 squared. That will be equal to square root of, just work this out from my calculator, 15 squared minus 14 squared, that's equal to 29. So we'll take the square root of this. That gives me 5.39 volts approximately. So that's the voltage across the inductor.